Hi, my name is Adam. Welcome back to GodotGameLab. In this video, we'll give a well-deserved overhaul for the cards visuals, and finally, we also make the cards playable in the game. So if I start to drag this block card over the card drop area and release it, you can see that I get 5 block, the mana decreases from 2 to 1, and I can also play the axe attack. I can't really play it over myself or any other invalid target, but I can play it over the crab enemy. And you can see that when I use all of my mana, I have 0 mana left. And this little change in the card visual indicates that I can no longer interact with the card or play it this turn. So let's get started. So let's open up the project. And before we start working on the cards, there's something I forgot to do in the last video. So for the enemy scene, if we open it up, you can see that we added this arrow, which indicates if we targeted this enemy, but I forgot to hook it up. So how it will work? If you remember, the enemy is an area 2D with the collision set up correctly. So it's on the enemy layer, or enemies layer rather, and it looks for collisions with the card target selector. And for the card target selector, this little cursor we move around when we aim with the mouse. The card target selector, if we open it up, it has an area 2D as well, which is set up the opposite way. So it's a card target selector and it targets the enemies layer. And that's perfect for us because if we hover over the enemy while aiming, the enemy's area will detect that card target selector entering it. And that's what we'll use. So if we go back to the enemy scene, select the area 2D, the root node, and go to node and signals, we need to connect the area entered and area exited signals to our script. So double click this, press connect. And if we select the enemy root node again, we can connect the area exited signal too. And if you remember, we have an onReady reference to our arrow. So what we can do is if we go down to those functions, we could do something like arrow.show. And when the card target selector exits this enemy area, we could do arrow.hide. And also just to get rid of the warnings, because we don't use the card target selectors area, by Godot convention, we prefix this with an underscore. So these two warnings will disappear. Save this script. And if we run the game again, and I use an aiming card, if I hover over the enemy, the arrow appears. And if I move it away, then the arrow disappears, so we can toggle. And this is just a good game design choice to indicate the player that the targeting mechanic works. Cool, now we can move on to the cards. So in the first step with the cards, we'll get rid of this ugly placeholder graphic. So instead of using words to describe the states, we'll use the mana cost and we'll use an icon for the card. To do this, let's go back to script, press Ctrl-Alt-O and open up card.gd. And we'll introduce a couple new export variables actually. So for the card attributes, we'll also define a mana cost, which is an integer. And for the visuals, we'll create a new export group so it gets isolated or separated from the card attributes themselves. And we'll use two things. First, a texture for the icon, and then a string for the tooltip text, which will be an export multi-line, because if the text is longer, it will be much easier to manage with a bigger text box. But we won't use this tooltip for now. We'll use it in a later video when we do the card tooltips. So let's save this script, go back to 2D view, and if we expand the characters folder and the warriors cards, we can double click those to modify them in the inspector. And you can see that we have this new card visuals group. So if we expand this, we'll have the cost, the icon, and the tooltip text. And you can see how using this export multiline gives us a much bigger text box. So for the X attack, the cost will be 1. And for the icon, we can load some sort of texture from the art folder. For this one, we'll use this X icon. We can leave the tooltip text empty for now. We'll deal with this in a later video. And if we double click the warrior block card, again we can expand the card visuals and set the cost to 1. And for the icon, we can load the shield icon we used. The tooltip text can be empty for now. Let's press Ctrl S to save everything. And we can move on to the next step. So the next step will be to update the card visuals from these placeholder ones we have currently. So from the scene tree, let's open up one of the CardUI scenes. And first of all, let's delete the placeholder color rect and the label. Select the CardUI, the top node, the root node, and click on the plus sign or press Ctrl A. And we'll add 3 nodes. First of all, a panel for the background. Then if we select the CardUI again, click on the plus again, we'll add a new label for the mana cost. And last but not least, select the root node again. And for the icon, we'll use a texture rect. Okay, so now all of them are added. Select all 3 of those new nodes and drag them above everything else. And for the panel, make sure that the size fits the card size. So go to anchor presets and full rect. For the label, first of all, let's rename this to something like cost. For testing purposes, we can type in a number like 2, maybe. And make sure that the horizontal and the vertical alignment are set to center. And under layout and transform, we can set the size to something like 10 by 10. And I think that looks perfect. And the top left anchoring we have here is also good, because we want it to anchor to the top left of the card. For the texture rect, let's rename this to icon. And let's select a texture so we can test how this looks like. So click on the texture property, load, and I'll choose this knife for this. And you can see that it's way bigger than it needs to be. So go to layout and transform. And for the stretch mode and expand mode, we'll use ignore size. And for the stretch mode, we'll use keep aspect centered. And now we can set the size to something like 10 by 10. This looks much better, but we need to anchor this to the center of the card. So click on the anchor presets and center. And I think that looks perfect. And now let's see the panel. Let's configure the panel. So we can create a new panel by going to Theme Overrides, Styles, and New Stylebox Flat. You can already see that the color has changed. And if we click on this new resource, we can set up the panel in any way you like. For the background color, I use this brownish color, but you can use anything you like. And for the border, I'll expand the border width and the border properties. And I'll use 1 pixel borders on each side. And for the border color, I'll use a gray color like so, but again, you can pick any color you like. And this panel we can reuse later on, for example, for the ManaUI display. So to make sure that we can reuse this throughout the project, I'll click on this Stylebox Flat and press Save. And we can save this under Scenes, CardUI, I think, with a name like card_base stylebox, for example. And now if we save this, we'll have this stylebox available and ready to reuse later on if we want to. Cool, now let's save the scene. And make sure we update the script for the CardUI to use these 3 new nodes. So let's click on the script icon. And if we take a look at the script, you can see that we still have these 2 placeholder onReady variables for the color rect and the state label. So we can go ahead and delete these. And if you have the scene tree on the left side, you can do a little trick. So if we select all 3 of these nodes, drag them into the script and press and hold Ctrl while we release the mouse, you can see that we have all these onReady variables generated for us. You can delete this empty line and save the script. That's it for this step really. And in the next step, we'll need to update the card states in the state machine we have. Because if you remember, we used all those placeholder colors and texts to keep track of which state we're in, but we no longer have those nodes available. So if I were to run this game, we'll get an error message saying that we can't set the color and the state properties for the card UI because we deleted those nodes. So if I stop the game, we can start fixing our code. So the base state is opened up by trying to run the game, and we can delete these 2 lines, save the script, go to the click state, delete those 2 lines, save the script, go to the dragging state, go back to the top, delete those 2 lines, go to the released state, delete the 2 debugging lines, and finally go to the aiming state and delete the 2 lines as well. If we save all the scripts and run the game, we should be able to see our new card visuals. And they look fine, but it still uses the cost and the icon from the card UI scene. And we wanted to use the resource to update the cost and the icon, right? Because we set it up. So for the blocking card, we want to see the shield, but for the attack card, we want to see the X. So let's close this for now. And let's open up the CardUIs script. So click on the script icon. And we'll update the code so it takes the resource into consideration to update the cost and the icon for the card. To do this, we'll use a setter function for the exported card property. And in this setCard function, the first thing we do is we check if the node is ready in the scene tree or not, because we need the node to be ready so we can change the icon and the text for the mana cost as well. And after it's ready, we'll change the card to the new value we have, and then the cost labels text property will be changed to the card resources cost, and the texture property will be changed to the resources icon texture. Now if we go ahead and save this script and run the game again, you can see that we no longer have the placeholder icons, but rather we have the 2 attack cards with the X icon and the defend card with the shield icon. But something weird has happened. If I start to drag the card over, sometimes it works, but if I'm dragging the X cards right now, and it doesn't work. Why? The card dragging mechanic should work still, right? And that's the thing with UI. It's easy to forget something. If we go back to the 2D view and take a look at these new nodes we have. Well, let's not forget that we need to always consider this mouse filtering option like we did before. So with this new panel, just like we had with the color rect, if I run the game and go to the debugger MISC, let's see what happens if I click on a card. Okay, now it works because I clicked on the icon, but if I click on the panel, you can see that the panel node under the card UI stops this mouse event, and I can drag the card. If I drag on exactly on the center of the icon, this 10x10 icon, then it works. But if I try to drag it where the panel is, it's no longer working. So in order to fix this, let's select the panel, and under mouse and filtering, set it to ignore. And just to make sure, if you remember, labels by default ignore mouse filter events. But let's see for the texture rect 2, it's set to pass, but we can set it to ignore as well. Save and run the game again. We no longer have this issue. I can drag the cards just like I did before. Cool. So we have the proper card visuals showing, but we still have a problem. If I start dragging this card, hovering over the card, it's not really interactive. There's no feedback on what I'm doing. And this is, from a user experience perspective, a pretty bad thing. So let's just fix this by doing different style boxes for when we hover over a card or when we start dragging it. That's what we'll do next. So if we go back to the card UI scene and select the panel, And we have this card base style box we created earlier. And one thing we can do is if we want to reuse the colors, we can click on this background color, and under swatches, if we click this plus sign, we'll have this color available throughout the project. So I just very quickly add the border color and the brown color to the swatches so we can access it later if we need to. And now what we'll do is we'll create a new style box based on this one. So if we go ahead and click on this arrow next to the panel, style box, we have this button called make unique. So if we make it unique, then it creates a new resource based on this one. And the only thing we'll change for the hover over effect is the color of the border. So for this one, I'll use a yellow color, like so. And again, we can add this to the swatches. And let's save this as a different resource, and we'll call this card hover style box. And we can do the same for the dragging style box. So again, click on this arrow, make unique. And I'm fine with this yellow border color for the dragging style. What we'll do is we'll add a new shadow. So for the shadow, let's set the size to something like 2 pixels. And for the color, I'll use the same color, the yellow one. So under swatches, I'll select the yellow one, but I can turn down the opacity a bit maybe to something like this. And it looks a bit weird in the editor, but if we run the game to see how it looks much better. It looks crisp and pixelated, right? But we don't want them to be in this dragging style box when we draw them. So we can go ahead and save this one too as its own style box resource. And this time we can call this card dragging style box. And we have 3 style boxes for the different feedbacks we want to. And in the CardUI scene, we can set it back to the base one. So I drag and drop the base one again. So when I run the game, the card will be in this state. So now what we need to do is to switch it out. So if I hover over the block card, it will change to the yellow border one. And when I start dragging it, it will change to the yellow border one with the shadow added as well. That's what we'll do next. And to do this, first of all, we need to change the script for the CardUI. So let's go ahead and open it up. And what we'll do is we define 3 new constants for the style boxes, and we can load them. So you can see I have this assign operator, but there's nothing on the right side. But if we go back to the file system doc, and I start to drag this over here, and I press and hold Control before releasing, you can see that it preloads this resource from the path we have. So I'll do the same for the dragging style box and do the same for the hover style box too. So the code looks like this. We have 3 new constants we can reference, and they have these 3 different style boxes preloaded and available for us to change in code. So where do we need to change these? So we need to change these in the different states we have. We'll start with the base state. So press Ctrl-Alt-O, search for base state, and open up the base state script. And in the base state, we'll do a bunch of new stuff. First of all, when we enter the base state, we'll set the panel's theme override to the CardUI's base style box. So every time we go back to the base state, we use the basic style box with the gray borders, but we'll also override the mouse entered and mouse exited callbacks. So when we enter with the mouse, again, we'll change the CardUI's theme override panel to the hover style box. And you guessed it, in the on mouse exited signal, we'll again override this style box back to the base one. And there's one more thing we need to do. We need to go to the dragging state. So when we start dragging, we'll go to this 3rd style box with the shadows added as well. So press Ctrl-Alt-O, search for dragging state. And when we enter the dragging state, we'll change the CardUI's theme override panel to the dragging style box. So with these changes, if we save our scripts and play the game, you can see that it looks much more interactive, because if I hover over a defend card, it goes to this yellow border, and it works with the other cards too. And if I start dragging it, it'll get this shadow, which looks much better in my opinion. And really that's all there is to it. We can wrap up the card visuals for now. We'll revisit them later on when we'll implement the card tooltips on the top of the screen. So we can move on to our next topic, which is expanding the UI's functionality, namely displaying the mana we have. And if you remember in our character stats resource, if I double click it and take a look at it in the inspector, we've already set up the logic for this. The character stats resource can handle this because we have a maximum mana and the logic for setting the current mana too. So how do we display this? Well, let's start by creating a new scene. So click on the plus sign, add a new scene. And the UI for the mana will be a panel node. So search for panel. Double click and rename this to ManaUI. And again, we can zoom in to see what's going on. And first of all, let's set the size. So go to layout, transform, and we'll use a much smaller box. 18 by 18 looks much better. And we can anchor this, so go to anchor presets and anchor this to the bottom left of the screen. And if we press W to enter move mode, we can move it slightly so it's not exactly in the corner on the screen. Something like this. Go back to select mode with the Q. And again, we could do something like go to the theme overrides and override it with a different panel, or just drag and drop the one we have for the card. But I'll show you a different technique here. But while we're here, we can use our theme, so the font will be the correct one. And go to theme, quick load, and load our main theme. And then we can add a new label as a child to this. Click on the plus sign or press Ctrl A, search for label. And we can rename this to mana label. For the anchor preset, we'll set it to full rect. And make sure to set the horizontal and vertical alignments to center. And we can type in the text box to see how it looks, something like 3 out of 3. And that looks fine, but the default panel looks a bit ugly. So if we go back to the ManaUI, this time we won't do a theme override, but we'll set the default panel in the theme itself to be the one that we use with the card as well. So if we click on this theme resource, we'll get this theme doc or theme window up here. And what we can do is we go to manage items, go to import items, and we can filter this and type panel. And you can see that we have the panel here, and we can import the style boxes. Click on import selected, close this window. And here we'll have this type panel, and we have all the different kinds of categories for the design. But we need the style boxes, which is this rainbow colored one. And for this panel, we can just quick load card-based style box. And you can see that, whoa, this looks crazy, right? Because in the theme preview, the background of the whole preview is a panel. So you can see how it looks in action. And if you click on this theme button again, you can see that our ManaUI updated its panel accordingly. Cool. So let's go ahead and save the scene. Ctrl S. We can save this as ManaUI.tscn. And that's all the setup we need from the editor side. Now let's move on to the coding part. So make sure that the ManaUI root node is selected. Click on Attach Script. ManaUI.gd is perfect. Press Create. And as usually, delete the auto-generated code. So what do we need to do in the ManaUI? Well, first of all, we'll define a class name for it so we can access it as a static type throughout the project. Then we'll have an export variable for the character stats with a setter function attached to it. Then we'll have an onReady reference to the label node we have so we can update the mana label accordingly. And in the setter function, we set our character stats to the new value. Then we connect the stats change signal to the onStats function we'll define later, but only if this signal isn't already connected. So I explained this in the last video, but just to reiterate, we do this because we want to be able to test this scene independently without its context. So to do so, we can set the export variable in the ManaUI scene, test to see if it works or not, And then we can later on inject the dependency however we want, and it would still work and wouldn't connect the same signal twice. Then we check if the node is ready in the scene tree or not, and if it's not, we wait for the ready signal, and then we call the onStatsChanged function, the same one we connected to the signal. And in this function, we do one thing. We set the mana labels text with 2 strings, the first string being the current mana, and the second string being the maximum mana we have. And that's all the code we need actually for the ManaUI. So we'll go ahead and save this script. And now we can instantiate this ManaUI scene in the battle scene. So if we go back to the battle scene and go back to 2D view, we can select the battle UI canvas layer node, click on the instantiate child scene button or press Ctrl+Shift+A, search for ManaUI, open this up, and you can see that we have our ManaUI here. And to test this, we can drag and drop our warrior character stats resource to the exported variable. And let's go ahead and play the game to see how it looks like. Okay, so it definitely did something because it became 0 out of 3, right? So it works. It sets the mana from the resource, but we might want to test if it updates or not, if we change the stats somehow. So to do this, we'll use some temporary code. So let's go back to the ManaUI's script. And in the ready callback, we can do something like this. We create a new timer for 3 seconds, wait for it to time out, and then set the character stats resources mana attribute to 2. So now if we run the game, you can see that it's still 0, but after 3 seconds, it becomes 2 out of 3. Okay, so the UI updates accordingly from the resource. Perfect, everything works fine. And that's really all there is to it for the ManaUI. Now, after we tested the ManaUI and it works, we can delete this temporary code because we no longer need it and save the script. So the next thing we want to do is to make sure that we can play the cards. But because right now, if we use our cards, what we do is we print out a debug message that we should play the card for the target. So make sure we can actually play them, and we can do some damage or gain block or anything we want. And to do so, let's refer back to our architecture from the first video. We can't start with the cards themselves because they rely on effects. And if you remember, I said that effects are the most important building blocks of the game mechanics, because we'll use effects to create logic for the cards. But later on, if we were to expand this demo to, let's say, introduce relics to the game, like in Slay the Spire, then relics would rely on using and composing effects as well. So what do we use for effects? If you think about it, there's really no reason to use resources because let's say that one of our effects is a damage effect, right? And cards and relics and enemies do different amounts of damage. So we could use a resource with an exported variable called damage or amount. But the problem with that is we don't really want to create like 20 resources for, let's say, 4 damage, 5 damage, 10 damage, 20 damage. That makes no sense, right? And either way, we end up having to rely on code to implement cards and enemy attacks. So why don't we just set that variable in code? And we don't really want to use nodes either because for the effects, we only use them in that portion of the code where we produce the cards logic or the enemy attacks logic. So what can we use? Well, let me refer to the documentation. So we have a nice article called When and How to Avoid Using Nodes for Everything. So we have 3 options if we don't want to use nodes. So we could use object, which is the most lightweight class we can rely on. But keep in mind that for objects, we must implement manual memory management. And I think that's a little too complicated for the thing we want to do here. And the second and the third options are the ref counted class and the resource class. The only difference between the resource and the ref counted is that the resource can be serialized or deserialized, meaning that, for example, we can save them in the file system. But if you think about it, we just talked about how we want to avoid this, right? We don't want to save all the different damage resources or the damage effect because there's no reason to. We don't want to keep those. We can do this from code. So we can use this ref counted class. Let's see what it says. Only a little more complex than object, they track references to themselves, only deleting loaded memory when no further references to themselves exist. That's perfect for us because we get the best of both worlds. It is lightweight, we don't need to save it on the file system, and we also don't have to deal with manual memory management. So that's perfect, we'll use this ref_counted class. Hopefully it will make more sense when you see it in action. So let's create this basic effect script. We could create its own folder. I saved it under custom resources in my reference project, even though it's technically not a resource. We can still say it's a custom type, so I think it makes sense to save it here with the other custom types we use throughout the project. If you disagree with me, you can save it in a different folder. For now, I'll just use the custom resources one. So right click, create new script. We'll call this effect.gd, and make sure it inherits not from the node and not from the resource class, but rather the ref counted class. Press create and double click effect.gd to open it up in the script editor. And this class itself is super simple. So first of all, we'll need a custom class name to use effect as a static type throughout the project. And then we only need to define one function. I call this execute. And we pass on an array of nodes as targets for the effect. And then in this base class, we actually do nothing. The pass statement means we do nothing. Why? Well, because all the other effects will inherit from this class, so this is basically a virtual method, saying that all specific effects, like the damage effect or the block effect we'll implement, need to have this execute function themselves, so we can create the logic for that specific effect. And notice that I used an underscore before the targets parameter here, just so we can avoid the unused parameter warning. And that's all there is to it for this simple base class. So let's save this with Ctrl S. And let's move on to something more interesting, like creating the block effect. So you can see how this works a bit better. So if we go back to the file system, first of all, we can collapse this custom resources folder, select the root folder, right click, create new folder, and call this effects. And under the effects, we'll create a new script, and we'll call this block effect. And make sure that it inherits from this effect base class we implemented just now. Create, expand the folder, double click the block effect to open it up in the editor. And let's see how we can do a specific effect. So how do we do this block effect? So first of all, we'll provide a class name, so we can use this as a static type, and we can create new block effects from script when we'll implement the blocking card, for example. Then we'll define a member variable called amount, which is by default 0. And this will refer to the amount of block we want to create by this effect. Then we'll override the virtual execute function we provided in the base class. And what we do is we iterate through all the targets. And first of all, if the current target is null, then we continue to the next one. Then we check if the current target we have is either an instance of an enemy or an instance of a player. And if it is, either of those can gain block, right? Then we get the target's stats resource, and we increment the block property by the amount this effect has. And that's all there is to it, right? And this is generic enough. Then whenever we'll create a new block effect, we just need to override or set the amount of block we gain. And we avoided having to create 20 resources for different amounts of block. So let's save this with Ctrl S. And we can do the damage effect next. So if we go back to the file system, right click the effects folder, create new script, call this damage effect, inherit from the effect class, create a new script, double click to open it up in the editor. And what we do here is pretty similar to the block effect actually. We'll provide a class name for the damage effect too. Then we have a member variable for the amount of damage we'll do. Then we override the execute virtual method, iterate through all the targets. If it's not a valid target, we continue. But if it is an enemy or a player instance, we'll call the target.takeDamage method, passing on the amount of damage this target needs to take. And that's it. We can save this script. And you'll see how we can use these effects in action when we implement the card logic next. Now we can move on to the biggest thing in this video, playing the cards themselves and implementing card logic. This is a pretty big task, so we'll break it down into smaller steps to make it more manageable. The first thing we need to do is to create a new event in our event bus, because playing a card is a pretty big deal, and a lot of different systems might need to do something when we play a card. So press Ctrl-Alt-O and open up events.gd and add a new signal called card played. We'll pass on the card which has been played as a parameter, not the UI but the resource, mind you, and we'll emit this later on from the card resources script when we play the card, so all other systems who care about this can be notified and connected to this signal. The next thing we need to do is we need to implement a couple new methods in the card resources script. So press Ctrl-Alt-O, search for card.gd, and open it up. So what do we need to do here? Well, we'll need a bunch of new methods, and the first of them will be a getTargets method, which will use to set the correct targets or get the correct targets as an array of nodes based on the enum we set for this card, because it can be self-targeted, single enemy targeted, all enemies, or everyone, right? And we need to set it accordingly, so when we'll play the card and we implement the logic for the cards, we'll have the correct targets already set up. So what is this targets parameter, an array of nodes? Well, it can be two things really when we play a card. If you remember, we have this debug message when we go to the released state. And we'll print out an array, the targets array, from the card UI. And that array either has the card drop area as a target, or that one specific single enemy which we targeted with our aiming system. So what do we do here? Well, first of all, if we have no targets, meaning that this targets array is empty, we have neither the card drop area, neither a single enemy passed on to this function, then something wrong happened and we have no valid target at all, so we'll return an empty array. Then we'll use the first element of this targets array, so either the card drop area or some sort of an enemy selected, to get a reference to the scene tree. So why do we need this at all? Let me move on with the script and we'll get back to this point real fast. Then we'll use a match statement for the target, which is the enum value for the available targets. And if you're not familiar with it, the match statement is similar to switch case in other languages. So when the target is ourselves, then what we do is we get all the nodes in the player group. And this is why we added the player scene and the enemy scene to their respective groups, so we can reference them here. So why do we need the scene tree? You can see that I wrote tree.getNodes in group player. When you think about it, we're inside a resources script. So what are resources? Well, resources are serialized data which usually sit in the file system. What that means is that resources exist in our disk even when the game isn't running. So when we write functions like this, there's no guarantee that the game is running at all. And for this reason, the resources by default don't have access to the scene tree. So what we do here is we rely on the node we have in the targets array to get a reference to the scene tree, so we can have access to functions like getNodes in group. I hope that makes sense. And so if the target for this card is all enemies, then we do the same thing, but with the enemies group, not the player group. And when the target is everyone, then we'll use both groups. We get the nodes in the player group, and we'll get all the nodes in the enemies group. And with the plus sign in GD script, we can merge the two arrays together. If something else happens for whatever reason, neither of these three, this is the equivalent of default in the switch case statement, then we'll return an empty array. So you could ask, okay, Adam, but why don't we deal with the part when we have a single targeted enemy, right? Don't worry about this, we'll deal with it, but not in this function. We'll only need this function when it's not a single targeted card. So for the next one, we'll have a play method, which will receive again these targets from playing the card, either the card drop area or single enemy targeted, as an array of nodes. And we'll also need to have access to the character stats because we need to check for mana. Then what we do is we emit the card played signal from the event bus, which we defined earlier. Then we subtract this card's cost from the character's mana. And this will be the place when we differentiate between single targeted cards and non-single targeted cards. So if it is single targeted, we don't need to do any of this match statement get3 magic we did in this getTargets function above. We can just pass the targets array because it will have that single enemy already in the targets array. So we'll call this apply effect function. But if it's not a single targeted card, then we'll call this apply effects function anyways, but we'll get the correct targets first by calling our getTargets method. And finally, this apply effects method itself is pretty simple here because it's just a virtual method. If you remember, we did the same with the base effect class. We had this execute method, which does nothing by default because it's a so-called virtual method. And we do the same thing here. We can say that all cards will have an apply effects method. And here we do nothing because those specific cards like the attack card and the defense card need to implement this function on their own. This is where we'll put the logic for each specific card. And you can see that we'll have an array of nodes for the targets themselves. And here, whenever we'll call this function, we will already have the correct target set up. Because in the play method, we already differentiate between the single targeted ones, and for the non-single targeted ones, we will just call our getTargets method to set up the correct targets for us. For now, that's all we need for the card.gd script. Save this, and we can finally code the logic for the block and the attack cards. Let's go ahead and do that. And if we go back to the file system, we can collapse the effects folder and go to characters, warrior, and cards. And here we can create the scripts for the X attack and the block. So right click the cards folder, create new script. And we'll call this warrior X attack. And make sure that it inherits not from the node, but from the card resource we have. Double click this to open it up in the editor. And you'll finally see why we did all that preparation and complicated stuff so we can make it easy to code and create new cards. So the one thing we really need to do is to override the apply effects function we just coded in the base card class. So what do we want to do when we play this card? Well, it's pretty simple actually, right? Because we just drag it over a single enemy and apply some damage, let's say 6 damage. So how do we do this? Well, first of all, we rely on the damage effect we created. So what we do is we create a new variable and assign a new damage effect to it, like so. Then all we really need to do is to set the amount for the damage effect to something like 6 and call the damage effect execute function with the targets we have. And because we already coded the damage effect to iterate through all the targets and call the take damage function on them, that's all the code we need for this card. Pretty awesome, right? So why don't we go ahead and do the block card too? So go back to the file system and under the cards folder, create a new script. Call this warrior block.gd and make sure that it inherits from the card class. And if we double click this and open it up in the editor, we can code the logic for the block card too. Pretty similar stuff actually. We'll override the apply effects method with the correct targets we have. We'll create a new block effect this time and store it in a variable, set the amount to something like 5 and execute the block effect for the targets we have. And if you think about it, for the attack card, this targets array will contain the enemy unit we targeted. But for the blocking card, the target will be the player scene. So ourselves. In this case, the block effect will execute on the player, so we'll add 5 block to ourselves. Awesome. So we still have one more thing to do because, okay, we coded all these cards, pretty simple, 3-4 lines of code. It looks fantastic, but how do we assign this to the resource itself? So how will we know when we play the card that this is the apply effects function we need to call for the blocking card, for example? Well, if we go back to the file system, there's a pretty neat trick we can use here. If I double click on the warrior X attack resource, you can see it in the inspector that it has the card.gd script attached to it. And that's a problem because if I click on this in the card.gd, this apply effects function does nothing, right? But the cool thing about it is if we go back to the warrior X attack script, it extends from the card class, right? So what we can do is if we select the warrior X attack, we just drag this new script and replace it with the previous one. And you can see that we have all the attributes still, even though we don't have them in the code. But remember, we extended it from the card class. So we have all the export variables we need here. For some reason, the icon gets deleted or reset when we do this, but That's not a big deal, I think. We can just go ahead and click load. And again, pick the X. And now it works fine. And you can see that we have this script attached to it, which means when we play the card and call this apply effect function, it will do all the stuff we coded here. So we can do the same thing for the blocking card. Double click this, drag the warrior block script to it, and again, reload the icon to this shield icon we have. Cool, we can go ahead and save everything. And in theory, we have everything ready to play the cards for real, right? But if we play the game, and I start dragging the shield card or the blocking card, still nothing happens. We'll only have the debugging print statement. So we somehow need to hook this all up with our state machine and the CardUI class too. So that's what we'll do next. So let's connect the pieces together. And next up, we'll change the CardUI slightly. So let's open up the script for the CardUI. And in the CardUI, to provide a way to call this play function we have in the card resources script, don't forget that we need to pass the character stats too, so we can subtract from the mana based on the cost of the card. So to do this, what we'll do temporarily is we'll set an export variable for the character stats, so we can test it out if it works or not. We'll do this in a proper way later on. And then if we have access to a character stats resource, then we can define our own play function for the CardUI script too. First of all, we'll make a safety check if we have a card assigned to this CardUI or not, because if we don't, then we can return from this function immediately because there's nothing to play. Then we can call the cards play method with the targets array we have set up in the CardUI and the character stats we set in the export variable. And then after successfully playing the card, we can queue free or delete this CardUI scene, so it no longer stays there forever when we release the card and play it. For now, that's all we need for the CardUI script. So save this. And then finally, we need a place somewhere where we can call this new play method we have in the CardUI script. So where do you think we need to do this? Well, if you guessed the released state, then you're right. Because if you think about it, this is where we have our temporary debugging print message to play the cards. So if we press Ctrl-Alt-O and search for released state.gd, this is where the magic will happen. And there's really not a whole lot to it. We need to replace this line with, you guessed it, CardUI.play. And if we go ahead and save this, then finally, we should be able to start playing the game with the cards. So if we run the game, and if I start dragging this block or defend card, and if I release it, we'll greet it with an error message. Why is that? It says invalid index mana on base nil. So if we move down one step at the stack, you can see that for the CardUI, we gave this new export variable for the character stats, but we didn't set it. So it doesn't know where to subtract the mana from because we have no character stats assigned to our CardUI. So let's go ahead and fix this real quick because I forgot to do it. If we go back to the battle scene, go back to 2D view, and select all the CardUI nodes at once, we can temporarily just drag and drop the warrior character stats to this export variable. And now if we play the game again, I should be able to drag this defend card, release it, and voila. We have added 5 block to our character successfully. And in theory, I should be able to aim with the card. And if I drag it over an enemy, it loses 6 health. You can see that I go to -2 mana, which is not that great, but I'll fix that in a second. And if I go ahead and drag this and drag it over the player or any other invalid place where we have no enemy, it goes back to the base state, but I can kill this crab enemy finally. Awesome. And I go to -3 mana, which we'll fix in a second. So we need to make sure that we can't play the cards when we don't have the mana to do so. And also it's a good idea to make sure that we can't interact with the cards at all when we are already dragging another one. So we'll tackle these two things at once. And first of all, we'll need 2 new game events in our event bus to handle this. So let's go to the script tab, press Ctrl-Alt-O and search for events. So we'll have two new signals, not just when we start the aiming process or end it, but when we start the dragging process or when we end it as well. With these two new events, we can save this script and go back to the CardUI script and change it once again. So Ctrl+O, CardUI.gd, and we'll have two new member variables, two flags in this case, one for playable and one for disabled. And for the playable, we'll have a setter function assigned to. So why do we need two different flags which sound like the same thing, right? Well, we do need to differentiate between the disabled and the playable state, because what I mean by playable here is if it's the card is playable based on the mana the player has, right? And what I mean by disabled is, for example, when we are dragging one card, we need to disable all the others to prevent the user from interacting with them. So these two cases are different visually as well. Because if a card isn't playable, for example, we can change the cost label to red to indicate this to the player. But we don't want to do the same with the disabled, because that would mean that even if we had the mana to play the card, all the labels would turn red when we started dragging one card. And that's not what we want, right? So we differentiate between these two cases, if that makes sense. And while we're here, we can also handle setting the character stats properly to the CardUI. So we'll assign a new setter function to the character stats variable called setCardStats. Then in the ready callback, we need to connect 4 signals from the event bus to our own functions, which will set this disabled property we defined earlier. So let's not forget that for the playable variable, we define the setter. So what do we need to do when this member variable changes? Well, first of all, we assign the new value to it, but then we'll check if it's playable or not. If it's not, we'll add the new theme color override to the cost label with the color red, and also make the icon transparent to further indicate to the player that this card can be played right now. Else, if it is playable, we remove the theme color override if we have one, and set back the transparency to the icon to 1. Then for the character stats setter function, we do two things really. First of all, we'll assign the new value to the character stats property, then connect the stats changed signal to our onCharStatChanged function, which we'll define soon enough. And then we need to define our 3 functions which are missing from this class right now. One is when we started dragging or aiming. And so what we do here is we set the disabled property to true, but not for the card we are currently dragging or aiming with. So why do we need this if check? How does this work? Well, if you remember, in the ready function, we connected to the event bus's signal for card drag started and card aiming started. Both of those are connected to this function, right? And so this is true for all the CardUI scenes in the scene, not just the one we are currently working with. So what we do here is we check if the used card, which we started dragging or aiming with, is ourselves. Because if it is, that means that this is the card we are currently dragging or aiming with, and we don't need to disable this, because then we wouldn't be able to cancel the dragging mechanic, for example. But for every other card in the scene tree, we want to disable them when we are dragging another one, right? And then when a card drag or aim is ended, for any reason, we set the disabled to false. But just because the card is not disabled, that doesn't necessarily mean we can play them. And this is why we differentiate between these two cases. Because if I right click to cancel moving a card, then it won't be disabled anymore, means I could interact with it. But if I don't have the mana to play it for some reason, then I still don't want the player to be able to start dragging the card and playing it. So what we do here is we say self.playable is equal to character stats, can't play card, and the card. And this function we implemented earlier will check if we have the mana to play the card or not. And we need that self dot before the playable because we are in the same class and we need to make sure that the setter function gets called, because this is where we set the font color to red if we have to. And our last function is the onCharStatChanged. And what we do is the same thing. When the stats of our character has changed, we need to set the self.playable based on how many mana we'll have left. That's all for the CardUI script. So we can save this. But we're still not done yet, because just by defining those two flags by itself does nothing, right? We need to use them somewhere. So we'll use those two flags in the two most crucial states, the base state and the dragging state. So let's start with the base state. Ctrl+O, search for base state.gd. And we do the same modification 3 times actually. So on the GUI input callback, we only need to check for transitioning into the click state if the card is playable and not disabled. So if either the card is not playable for some reason or it is disabled, we can return from this function immediately to prevent from interacting with the card. And we do the same with the onMouse entered and onMouse exited callbacks too. Because if a card is disabled, we don't want to indicate the player that somehow they can interact with it by changing the style box, right? We only want to change this if we can play the card. Cool. That's all for the base state. We can save this with Ctrl S and Ctrl Alt O to open up the card dragging state. So here in the card dragging state, we don't really have to deal with the interaction stuff we did with the base state. But let's not forget that we have 2 new events in the event bus, the card drag started and the card drag ended signals, and we don't really emit them anywhere. So that's the place we want to do this, right? So when we enter the dragging state, we can emit the card drag started signal. And where do we want to emit the card drag ended one? If we scroll down to the on input callback, you can see that we can transition to 3 different states from this one. So we could do something like emit it right here, then emit it here, and then finally emit it here. But it's much easier to just provide an override for the state exiting function. And when we exit the dragging state to go to whatever other state we want to, we can emit the card drag ended signal. And that's all the setup we need to be able to set whether we can play the cards or not. So how do we test this? If I run the game now, I have 0 mana and I can still play the cards. And I can hover over them. Does that mean that it's not working? Well, not really. If I start dragging this block card and release it, you can see that when I play it, I have 5 block and I go to -1 mana, but all the other cards become unplayable and I can no longer drag them and interact with them in any way. So why is that? It's because we haven't really set it to initially check if the card is playable or not, because if you think about it, in the real game, when we finish the project, we'll never start our turn realistically with 0 mana. And we don't really have the specifics implemented yet to turn management and card drawing and all that good stuff. But for now, let's see a temporary way to test this. Let's go back to the ManaUI's script, actually. Ctrl Alt O, go to ManaUI. And again, we can override the ready function like we did earlier. So we can do something like ready and do character stats that mana equals 2. And to make sure that we don't do this immediately, again, we can await a scene 3 timer to expire. So get3.createTimer. Let's do 2 seconds and the timeout signal. Cool. So let's see if that works or not. So now if we play the game, our mana gets updated to 2. And if I play 1 card, it goes to 1. I can still play my cards like before. If I drag this over, I can no longer play my last attack card, so I can't kill this crab enemy. And just to make sure, and to show you it really works, what happens if I set the mana again to 0 from 0, after 2 seconds, it will still trigger the stats changed signal. So if we go to the game, wait for 2 seconds, you can see that it's still 0, but changing the mana triggered the setter function, so we can no longer play the cards. And this is perfect because when we'll do turn management later on, we'll always reset the character's mana at the start of the turn. So we don't really have to deal with this issue we have right now. I just wanted to show you that everything works fine, just the way we wanted it to. Awesome. So we can delete this temporary code again. So one final thing I wanted to do in this video is to make the hands card order a bit more consistent. And what I mean by that is when I start dragging whichever attack card and cancel out the movement by right-clicking, you can see that it goes back to our hand and gets reparented correctly, but we end up with the attack card being the last one. So it doesn't go back to the original index, the original place it was before. So let's go ahead and fix that. And to do so, we'll go back and revisit the CardUI script one last time, promise. So press Ctrl Alt O, search for CardUI, and we'll have a new onReady variable called original index. which will be the card's original index when we run the game. Then we need to modify the hand script, which we haven't visited in a while. So let's give him some love, Ctrl-Alt-O, hand.gd. So what do we need to do this? First of all, we'll need a new member variable to keep track of how many cards we played in this turn. So we call this cards played this turn and make it equal to 0 by default. And in the ready function, we'll connect the card played signal from the event bus to our own function called onCardPlayed. And when we do play a card, all we need to do is to increment this cards played this turn variable by 1. And then we can change the CardUI reparent requested callback. So first of all, we need to calculate the new index of the CardUI. And how do we do this? Well, what I did here is I took the original index of the card and I subtracted the amount of cards we played this turn. And just to make sure that we don't get too crazy, we can clamp this variable between 0 and getChildCount, means the index can never go out of bounds in relation to the number of CardUIs this hand has. And then after calculating the new index, we call this moveChild function and move the CardUI we want to reparent to its new index. And we'll use call deferred here to make sure that this happens at the end of the frame. So now if we go ahead and save the script and run the game again, if I drag this X attack and right click to cancel it, it no longer pops at the end, but rather it pops back to its place where it was before. So that's it for this video, and I'll see you in the next one. Bye bye.